In this video, we're going to go over another example of an equilibrium problem where you can use rice tables to organize your thoughts. If 0.450 moles of pure phosgene gas were placed in a 2.50 liter evacuated container and the equilibrium constant K equals 19.9, find the equilibrium concentrations of all species. So the first thing we need to do is look for the balanced chemical equation for this problem. There's our phosgene gas, and it will decompose into carbon monoxide and chlorine gas. Okay, now let's continue that rice table. I feel like we've got some pretty good starting information about the phosgene gas, or the COCl2. Unfortunately, we don't have any concentration values yet. However, we know that molarity equals moles divided by liters, and our problem definitely gave us both of those values. So really quickly, we'll do 0.45 divided by 2.5 in our calculators to get 0.58. The question also states that our original phosgene gas is placed in an evacuated container. This implies that our starting concentrations of carbon monoxide and chlorine gas are both 0. Okay, now this question doesn't give us any direct clues to the concentrations at equilibrium, but we can make the assumption that some reactants will make some products, since there are currently no products. We will keep this amount as a variable while we puzzle out the situation. We'll call this variable x. We know that some x amount is going to leave the reactant side, and since there's a 1-to-1 ratio for all of my chemicals in the balanced chemical equation, we know that that same amount of concentration will increase for my products. Now, we can add up the initial boxes and the change boxes to get an algebraic expression for the equilibrium conditions. We'll get 0.580 minus x for the phosgene, x for the carbon monoxide, and x for the chlorine gas. Now that I have algebraic expressions for my equilibrium concentrations, I can substitute them into an equilibrium constant expression. The equilibrium constant expression for this reaction will have the concentrations of my products with a 1 for an exponent, so we won't write it, and phosgene gas on the bottom. Okay, our problem tells us that the K value is 19.9. And now we have expressions for our individual pieces at equilibrium. We can see that x times x is just going to be a plain old x squared. So I'll rewrite my expression so it looks a little bit more clean. Okay, now we can multiply the 0.58 minus x to the other side of the expression to get our x squared is equal to 11.542 minus 19x, performing that distribution during that step. Okay, just one more step. I'm going to add my stuff on the left over back to the right side to make it so that my answer looks like a quadratic equation. At this point, we can use the quadratic equation, which, if you recall, is negative b plus or minus the square root of b squared minus 4ac over 2a. And I will plug in my a, which is 1, my b, which is 19.9, and my c, which is negative 11.542. I'll number crunch these in a calculator to end up with two different x values. The first x value seems a little absurd. I got negative 20.464. My second x value seems much more reasonable for this physical scenario, 0.564. That number seems reasonable to me because my phosgene is starting at a concentration of 0.58. Subtracting a number smaller than that number is physically possible. Subtracting a negative number or adding to this concentration out of nowhere is definitely not possible. Okay, now it's time for me to reread my equation and make sure I'm answering the question. We are supposed to find the equilibrium concentrations of all species, so we are really close. Two of our species are already found. The carbon monoxide is just the value of x, so we can write down that value as 0.564 molarity. Same thing goes for the chlorine gas. Our last question is the phosgene concentration. So I will do 0.580 subtracting our 0.564 that we got for the x value to arrive at a final answer of 0.016 molarity. This type of rice table problem is extremely important, and we can use it again and again as we encounter other problems about acids and bases, and also for solubility. Please make sure that you do enough practice problems to become proficient at using your rice tables.